Okay, this video is for the wedge, and the wedge is pretty straightforward. When we think of a wedge, we usually think about the stopper that we put when we're trying to hold the door from closing. But the wedge can be many other things as well. The wedge can be knives, and I think one of the most popular wedges that we think about would be like an axe, right? Or in this particular scenario, we have a device that's trying to split the wood and we're actually hammering it into the wood, right? Okay, so let's look at the definition of a wedge. The wedge is used to separate two objects through the application of force. Okay, it's made up of two inclined planes that meet and form a sharp edge which can split things apart, right? So if we look at what a wedge is, we can see that it is made up indeed of two inclined planes, okay? So if it splits something apart, then it's a wedge. So it can be used as a separation, or as a holding device. Okay, so the wedge IMA is pretty straightforward. Again, DE over DR. Okay, we just have to define what the DE and the DR are going to be for the wedge. Okay, so very similar to the inclined plane, the DR is going to be the height and the DE is going to be the length. Okay, and this assumes that the entire wedge is actually being pushed into the device that's splitting. Okay, and I'll talk about that just a second. But here, that would be essentially 10 over 3. Okay, and that would give us an IMA of 3.3. Okay, so this is what I was talking about. Okay, so here we have a wedge that's going to go into the splitting device. All right. Now, the distance effort is going to be up here at the top, right? Okay, and the distance resistance is going to be on the opposite sides of the inclined planes. So pushing apart. Okay. Now, the distance traveled by the effort force in this particular case would be only part of the wedge, right? But if this wedge here, actually all of it went into the splitting device, right? So let's say that the entire length of the wedge went into the splitting device, then the DE would actually be equal to the length of the wedge itself, right? And that's what we had previously said. So moving forward, that's really what we're going to assume. We're going to assume that the entire wedge is actually being pushed into the splitting device, okay? And then the DR would be the distance that is traveled by the, it would be the distance traveled by the two pieces that are splitting, right? So if this entire wedge is inserted into this device that's splitting apart, then the distance traveled by the load would indeed be the height, right? So DR would be equal to H, right? So that's exactly what we said. So if we go back, we can see that the IMA is equal to the L over H. Okay, and when we talk about the AMA, it's still FR over FE. We just have to define what the FR and the FE are, right? So we said that the FE is going to be at the top of the wedge. So think about that hammer that's hitting that wedge into the piece of wood, right? The effort force is being applied at the top, and the resistance force is on the sides of the inclined planes, right? So that would be here. Okay. So the AMA of the wedge would be the 700. So the FR is 700. And then the FE is going to be 250. Okay, that gives us an AMA of 2.8. And then if we look at the efficiency, we just divide the AMA by the IMA. We just divide AMA, we take the ratio of the AMA and the IMA, and we get 84%. Okay, so here's a problem. What is the AMA of this man? He's using an axe to split this wood apart, right? So right here, this would be our FE, right? And then coming out of the splitting device would be the FR. Okay, so if our FE is 300 and our FR is 800, what kind of AMA do we get? 2.67. Okay, so that's pretty much it. That's what I had for the presentation on AMA. I did want to cover what was on the board, and what's on the board is essentially what I had just talked about. Okay, so you have a splitting device. Let's see here. Yeah, so you have, here's the, let's say that this is just the wood, right? The wood, and it's not yet split. And up here we have the wedge. Okay, now if we drive the wedge into the piece of wood and split that apart, right? We said our FE is going to be up top and our FR is going to be perpendicular to our FE. And then we said the distance traveled by our effort force is going to be the DE, and the distance traveled by our resistance force is going to be the DR. But we're going to assume that the entire wedge goes into the, in this case we're calling it a piece of wood. Then our DR would simply be the H, and our DE would be the length of that wedge, right? So if we had a, let's say we had an axe, right? Here. Here's our axe. It's a pretty bad axe, but that's an axe, okay? Then the IMA of this axe would be, we define this as H, we define this as L, right? Would be L over H, okay? And then the AMA is just the FR or the FE. And that's it.